Welcome students. Today we are going to learn about simple microscope. So what is a simple microscope and what are the calculations involved in that? So simple microscope, simple microscope, it is a device which magnifies. You might have used this in biology labs. Okay, it consists of a simple convex lens, and using this convex lens, if you try to see an object, okay, it magnifies the image. So basically here what we do is, this is the object actually, this is the object. So the image will be formed. We have to find where is the image formed. So a convex lens will have two focus points. So you can take, we have to take two rays actually. So one which is parallel and one which is passing through the optical center. So it will be formed somewhere here. You can see the one which is parallel, it will pass through the focus. So the intersection point of these two rays, let us say it's somewhere here. This is the point where image will be formed. Okay. So how does a simple microscope magnifies means? Let me put some names here: A, B, C, D, and let us say this point is O. So the eye of the person is somewhere here actually. So he is looking in this direction. He is seeing this object actually here. Okay. So you can see that the size of AB is greater than the CD. So that means it has been magnified. So here we write magnification as a quantity called M is equal to, we are talking about here angular magnification. So we have to take this angle, how much the angle is magnified. So that is beta by alpha. Beta is the angle created by the object, and alpha is the angle created by the, beta is the angle created by the image, and this is by image, and this is by object. Because they are almost in the same line, so we will take this CD line here actually, okay, like C prime, D prime. I'm just taking the projection here just to take the angle. So this angle will be alpha, and the angle made by the projection, this image projection is beta. So you have two triangles like this. One is A, B, O, where beta angle is made, and another is, this is by the image and this is by the object. It is C prime, D prime, O. This is the alpha angle. Okay. So because these angles are very small, so for very small angles we can write the angle as the ratio of tan beta by tan alpha. So tan beta means you have to take this triangle. It is AB by OB, and this is C dash D dash by OB dash. Okay. So you can see here that this in this triangle actually, but you can say that AB is almost equal to C dash D dash, because if you're finding this angle, see, this is the beta angle. So if I am taking, see, this is the object distance, this distance is the object distance, and this distance is the image distance. Okay. So when you write a tan beta, you can write this as CD. This you can write it as CD actually. Okay. So CD and C dash D, because if I take A dash, this AB dash, if I take, now I have to take the full distance. I want to avoid that. I want to take only this distance. Okay, so these two can be cancelled out, and you are left with OB dash by OB. So what is OB dash? OB dash, that is this point. This is the image distance by the object distance, because you are measuring opposite to the direction of rays. The rays are coming like this and you're measuring like this, so you have to take these as negatives. So this minus minus anyway becomes plus, so it is V by U. So this is your magnification. So now we need to understand here that the minimum distance that is required for clear vision is 25 centimeters. Usually we take that as capital D is equal to 25 centimeters. So we are saying that the image is formed at this point, at the point of minimum distance. So V is equal to D. So this can be written as V is equal to D, means this becomes D by U. We'll apply the length equation here. Length equation says 1 by V minus 1 by U is equal to 1 by F. So multiplying with V both sides, you get 1 minus V by U is equal to V by F. Why we are multiplying with V means in the magnification the formula is V by U. So this can be replaced as 1 minus M. Now V is equal to minus D, and focal length. Focal length is a positive quantity for convex lens, because both are in, focal length is formed here, right? So both are in the same direction, so it is positive. So this becomes M is equal to 1 plus D by F. So this is the formula to calculate the magnification of a simple microscope. So these results are used often in the calculations of simple microscope, and this result is directly used in the calculation of compound microscope. Thank you.